Project 21002, Improved Instrument for Making Ultra-Sharp Glass Knives.
Robert Acker, and I'm a mechanical engineering major.
I'm Mohammed Al Khalifa. I'm a mechanical engineering major too.
Saud Al Sabay, I'm industrial engineering major.
I'm optical science and engineering.
I'm Benjamin Heald. I'm a mechanical engineering major.
Dror Sapir, Optical Science and Engineering. The contents of today's presentation are as follows. This is our design day poster. It includes background, problem description, major system requirements, system components, results, conclusions, and acknowledgements, all of which are discussed in this presentation. A little bit of background. The glass knife maker, GKM2, is an RMC Beckler product that produces ultra-sharp glass knives for ultramicrotomy and cryo-ultramicrotomy. The GKM2 is considered one of the best instruments for producing ultra-sharp glass knives. However, the design needs modifications to improve its appearance and usability while maintaining its competitive price and performance. This is the project scope: to improve the old design while maintaining quality of the glass knives, ensure that the new design is simple, durable, and mechanically sound. And some major improvements are aesthetics, user-friendliness, consistency, safety, efficiency, and compactness. Balanced break method. Glass specimen is scored and broken down into 2 equal halves until a square is produced. Here are the steps for the different parts. Each glass square is scored and broken along its diagonal to produce 2 ultra-sharp glass knives with blades on opposite ends.
So this was our overall approach to the problem. First, we developed SolidWorks models, and then we iteratively updated the SolidWorks designs based on sponsor feedback. Once this was done, we purchased all of our COTS parts. Then we delivered our drawings to Xometry in order to fabricate our custom parts. Although we didn't have enough money to fabricate everything, so we only fabricated what we could. And then we 3D printed the covers that went around the base for aesthetic appeal. And then finally we assembled, integrated, and tested our product. So these are the major system requirements for our project. The first one, quantity of cuts. So the glass knife maker, or GKM, shall be able to produce ultra-sharp glass knives such that the glass knives make at least 10 cuts through the plastic resin used for ultramicrotomy. Second, the quality of cuts. The 10 cuts mentioned above shall not leave knife marks that are visible through the stereo microscope under 70 times magnification. GKM shall score the top surface of the glass. Aesthetics was another major system requirement. The GKM Pro shall be aesthetically pleasing in the eyes of Beckler instruments. This is our overall system block diagram. For the glass knife maker, it is split up into 4 major subassemblies, the top left being the positioning subassembly. The purpose of the positioning subassembly is to position the glass specimen prior to scoring and breaking. And you have top right pressure readout assembly. The purpose of that subassembly is to display the pressure applied to the glass. Then you get the mid right, we got the pressure application assembly. The purpose of this subassembly is to apply pressure to the glass specimen in order to break it after it's been scored. And lastly, in the bottom right, you have the scoring subassembly. This is responsible for scoring the top surface of the glass in one smooth and continuous motion.
The 2 main objectives of the point design were to update the aesthetics of the GKM and rework the functionality of the GKM while keeping the same quality of glass knives cut. We improved the aesthetics of the design by replacing the blocky square style of the older GKM with smoother curving features and by nesting the pressure readout inside the GKM base. Some of the important ways functionality was changed includes changes so that the glass is scored on the top side, and the glass can easily be positioned with a slider rather than with stationary stops.
Here we have our requirement verification table. Due to us having trouble finding a machine shop, we still don't have all of our parts machined in time and assembled. Because of that, we have marked many of our system requirements as failed, as you can see here in the table, since we were not able to do the testing for them yet. Some of our system requirements have passed, like scoring, for example. The current GKM model that Beckler have scores the glass from the bottom, and the team from Beckler made it clear to us that it is important to model the GKM so that it scores the glass specimen from the top. And we were able to do that, as you can see. And here we have some of our basic system requirements. As you can see, 4 of those have passed and only 2 have failed.
Here's a look at a couple of the design iterations we had on the GKM. The first one on the left is what we had at PDR, and that captured the general shape of the base that we wanted and the components that we wanted to move. By TDP, we had each done subassemblies on the scoring, pressure, and positioning, and they all fit together on this model here, a bit rough. And then we were able to refine that to get our final version on the right here.
We were unable to make a complete working prototype due to budgetary shortcomings and time constraints, but we are currently building a prototype. We will use this prototype to simulate the scoring and positioning of our design. Also, we will be using the old design to apply pressure and break the glass. This will ensure that the new design is at least as good as the new design.
Here are the parts that are available currently. There are 3D printed base and a cover. All of the subassembly will be integrated into these 2 parts. The scoring, pressure readout, and the pressure application assembly will be integrated to the cover mostly. And the position assembly for rectangular glass and square glass will be integrated to the base. At the end of this project, we will deliver a SolidWorks model of a redesigned GKM, a prototype of a redesigned GKM, technical data package, and an operating manual. During this project, the most outstanding difficulty is integrating all of the parts because we need to tweak in all the parameters to make sure all sub-assemblies will not interfere with each other. Besides, sponsor machine show was behind schedule. As a result, we are not able to obtain all of the parts in time. Since the project went over budget, the team asked the sponsor for additional funding. However, we did not obtain additional funding. Therefore, we only manufactured score and position assemblies.
During this project, we have learned many lessons. We should always consider the lead times corresponding to the machining process when making a design. Second, we should ensure that all drawings are properly turned prior to machining. This will help us avoid rework and its cost. Third, we should always establish a critical path for the project. This will help us have a good understanding of what are the critical tasks and what is the total length of the project. And finally, I would like to thank everyone on behalf of my team from Beckler and everyone else that has helped us during our capstone project.